So today we are going to talk about a topic which is not that discussed, and that is decimal representation of rational and irrational numbers. And so all of you might already know what rational numbers are. They look like this: P over Q, where P and Q are integers, and Q is not equal to 0. Yeah, it's like this. And irrational numbers is anything which is not this. So rational numbers look something like this. They 4 by 1, or just simply 4, or also square root of 16 is also a rational number because it can be written as 4 over 1. So these are all rational numbers. 3, 7, 4, all of these are rational numbers because they can be written like this in the form of P over Q. 4 by 3, 27 by 9, all of these are rational numbers. Now, irrational numbers is anything which cannot be written like this. For example, the square root of 2, or 7 over the square root of 5, or the square root of 5 over 16. These are irrational numbers. Now, when we look at decimals, okay, we get two types of decimals. First of all, we get terminating decimals. Regarding terminating decimals. And now, when do we get these types of decimals? So first of all, what are terminating decimals? So they are decimals which have only a finite number of digits in its decimal part. For example, we have 202.04. We could also get 54.0001 or 26.92357, and the terminates over here are also 0.00001. This is also a terminating decimal. Okay. So all of these are examples of terminating decimals. Now, since a terminating decimal can be converted into a common fraction, and I'll get to that in a moment, every terminating decimal represents a rational number. The second thing we are going to discuss are recurring decimals. And these again are another type of rational numbers. In general, a recurring or periodic decimal is a decimal in which one or more digits repeat indefinitely. And these can be actually converted into common fractions, and I will show you that too in a moment. And so yeah, every recurring decimal represents a rational number. Terminating decimals, recurring decimals might look like this, and these go on and on. These may also look like this. They may also look like this: 1 2 3, 1 2 3, 1 2 3, and so on. These are recurring decimals. Now, so a non-terminating, non-recurring, let me write it down, a non-terminating, okay, and non-recurring decimal is a decimal which, again, it neither terminates or recurs. These types of decimals represent irrational numbers, because it is not possible to convert such a decimal into a common fraction. Thus, again, a non-terminating, non-recurring decimal represents an irrational number. Now, let me just give you examples of what I've just discussed over here. So, let's discuss, well, we actually discuss over here this number, 0.25. This is a rational number, and it is equal to 25 over 100. So we've put this in the form of P over Q, yeah? And here we have another one, which is 0.333. This can also be put in a fraction form, 1 over 3, which is again in this form, P over Q. Again, P and Q belong to the set of integers, and Q is not equal to 0. Okay? And then we've also got 2, and this line over here shows that 3 is recurring, and this can also be written as a in this form. And so can this number, 0.142857142857 1428571428557. This is recurring, and this can actually be written as 1 over 7. Now I'm going to talk about something which is a non-recurring and non-terminating decimal, which looks like 0. That's a 0. 0.01001000100001. This is a non-terminating and a non-periodic decimal, so this is an irrational number. I can give you another example: 214.121122112222. This is also non-periodic, non-terminating, and non-recurring, and this is also irrational. Any non-terminating, non-recurring decimal represents an irrational number. It could be anything, even pi, pi 3.14, and so on. It is a non-recurring, a non-terminating decimal, so it is also an irrational number. Yeah, so because if you look at pi 3.141592654, I mean, there are websites online which give you like the first million digits of pi or something like that, and nothing repeats, and the number doesn't terminate. The digits do not terminate, so pi is also an irrational number.